How's it going, everyone? Happy Monday. We're getting set up here. The idea is we're going to continue on with our Pytorch tutorials that we've gotten along with pretty well so far. We finished our LSTM last week, and you can see this on the screen, our LSTM here, which got really good rates of loss. So today we're going to continue on with our Pytorch tutorials where we've been working on getting through the main second portion. So we're going to walk through a couple of these here. So we just did our LSTM. We're going to quickly just walk through a little bit of, actually, we'll just read through some of this. And then I believe we're going to get to TensorBoard. I think that's the plan. We're going to get to TensorBoard here. Maybe today. I think so. I think we'll get to that. Let me see here really quick. All right. Let me just get my windows all set up. Here we go. Oh, hey, Asoki. Good to see you. What's up, man? Currently, my assessment is to solve the Sarif 10 problem. Oh, with AI, with a convolutional neural network, only with fully connected layers. Got any tips? Oh, well, that makes it easier, right? Can you do that? I think you might be able to. So you just need to get your hyperparameters tuned properly, right? So are you going to use what is your optimizer? What are you going to be using on your learning rate? Do you want to do early starting? So do you want to pre-warm your AI, right? So you could do that with I think. Pre-tune it with smaller learning rate at the beginning for like 10 minutes and then increase that learning rate a little bit later on down. I guess maybe Adam W works as well. You only started deep learning. All right, that works well. Multi-layer perceptron, got to get that deep learning. Just stack on those layers and that'll do the trick. That'll do the trick, yeah. You also want to look at what your activations are going to be between each of the layers. I recommend TAN-H. I like TAN-H because it reaches down a bit. It gives you an extra bit. It gives you one extra bit to work with. TAN-H for activation. Let's see, ReLU has a loss on your. So ReLU is faster. It is. It's just it has a loss. So if you're looking for accuracy, so you might try ReLU. There's GelU as well, right? So activation, you use GelU and ReLU. I like TAN-H is my favorite. I like TAN-H. And also look at Dropout. You could look at, I think there's different types of, there's L1 and L2 regularization. And I think Dropout is like L1. We're going to talk about that today. I was looking through this. So there's a Dropout segment right here. I think we're going to look through this real quick. Yes, right here. And it's really easy. It's really easy. It just adds randomized, it randomizes your training data. Hey, Jinlu, good to see you. Welcome on in. Oh, hey, there's an empty RAM module I posted earlier. I responded to it. You want to buy a RAM stick without any RAM on it? What are you doing? Original new 100% quality RAM-less RAM stick. There you go. DDR5, a bus, what is it? You can buy RAM without RAM. What a world we live in. Isn't that crazy? Hey, how's it going there, Martin Coders? What's up? What's up? Good to have you here. Happy Monday. We're going to go through our Pytorch. We're going to go through a little bit more of the Pytorch tutorial here. So what happened was, here, check this out. What we did was we started going through recurrent layers a couple weeks ago. And then we started diving a little bit deeper. And then we saw here, there's like this really beautiful, oh, 1 second. 1 second here. Click that button. Let me get the music good. Okay, got it all set up. Yeah. And the LSTM, we were like, oh, hey, look at this. And so we wrote it and realized, wait a second, it's missing a whole bunch of things. And so I went in and I filled in all the missing details and I got it right. We got it right. It only took us a week. And then we went through another week and there was a tutorial right here that we went through. We went through this tutorial. We went through the whole thing. And that took us another week. So we got distracted. And now we're going to resume where we left off. It's been 2 weeks. Angie. Hey, Angie. Good to see you. Welcome on in. Happy Monday. You applied to data engineering internship in Bosch. Oh, nice. For your mandatory internship. You hope you get it. Yeah, if it's mandatory, you hope you get it. Why are there 2 Stevens? Are there? Wait. What do you mean? Jinlu, what do you mean? Wait. Who's the other? Hey, Loons, good to see you, Loons. I saw all of your comments. I responded to your comments on those videos, Loons. Good to see you. Welcome on in. Happy Monday, Loons. No, like earlier. Oh, yeah. That's because it was automatically playing. It was playing this. That's why. All right, I forgot to loop it. That's why. Oh, okay, yeah, exactly. Just saying hi, can't stay long. Loon, sounds good. Happy that you're here. Attention is all you need. Hey, Soki, yep, you remembered it. Transformers. The BERT, bidirectional encoder representation of a transformer, or something like that. What does BERT stand for? What does BERT stand for? Bidirectional encoding representation, something like that, right? BERT acronym. Acronym. Thank you. Bidirectional encoder representation for transformers. I told you. The music is great, isn't it? You know why? Because Jin Lu wrote it. Jin Lu wrote the music, you guys. This is Jin Lu right here. It's Jin Lu's music. Jin Lu is in chat. I like it. Hey, Clips Merge, the multiverse of Steven. Exactly, Clips Merge, good to see you. Welcome on in. You can encode text with BERT. It's pretty cool. I know, it's pretty cool, yeah. I like the encoding. I like the encoding part of it. And we will be building an embedding. We will be doing an embedding. I think it's around here, yeah. So we are gonna do maybe a whole week of embedding. We're gonna go through this. Basically, it takes your one-hot encoded vectors, which are representations of your tokens, and it converts them into an embedding, so that way it's easier to derive meaning. Also, it compresses your data into a smaller space, so it makes it easier when you're putting it into a feed forward. It is Jin Lu's music. Yeah, it sure is. You feel like you're on a Wii? Oh, like a Wii Nintendo? A Nintendo Wii? Why don't you look real? Oh, it might be the subtitles. They look fake, right? No, but they look like it's pre-recorded. But it's not pre-recorded. It's live. Isn't that crazy? Anyway, you're trying to fix old broken mini keyboards. Nice, Jin Lu. Missing parts, so now you have to go look for alternatives. Makes sense. What's your age? Oh, Signal. All right, Signal Internet. I'm in my 40s. We're at retirement age here. We got the young people need to take over, and so we're walking through all of the AI. Nintendo Wii, you got it. Can you do term frequency vectors as well? But they are not as strong. Oh, interesting. Yeah, I like the idea. We take one-hot vector encoding, and we convert it into each token will get some numbers. So that way, say if you have a very large token dictionary, like 10,000 tokens, you don't want every word on the input through your feed-forward neural network to be 10,000 tokens. It's too much. So you have to compress it. And you can do that. You can do that pretty well. We getting back to the streams? Oh, yes. Oh, when we getting back the fun streams? Oh, Clips Merge. You mean like when we did the drawing? Like these kinds of things when we did live drawing on the screen? You remember that? We also had these over here. The drawing, and then everyone else could draw at the same time. Thank you for clicking that. Yes, those? Yeah. So we might do those. Right now we're doing AI. You know what? We are going to go through some more visuals. I believe we should be able to get to our, what do you call that? Where is that at here? In this one. Here we go. We're going to go over to TensorBoard here. We're doing all AI, so let's pin this one here. So the plan is we're gonna go for this next. However, there's a few things that we don't want to miss. I don't want to miss anything. I don't want to miss it. So we're gonna go through transformers, data manipulation, dropout, normalization, regularization, and we might walk through some of these things here, like a quick, easy activation loss. So that's the plan for today, and we might get to TensorBoard. I think we might be able to. Signal Internet, any advice for people in their 20s, you're 22, with a full-time job as a software dev? You ain't getting that kick. Wait, you ain't getting that kick. You want to move into some real tech, maybe low-level programming or something with ML. Yeah, that's where it is. All right, check this out. everyone's vibe coding these days, right? There's so many vibe coders, and they realize how powerful it is to use these chat GPTs and Claude codes to write software for them. They're realizing, though, there's something that's missing. An aspiration or a drive or a desire to actually have the discipline to continue to maintain the application they've built. It's a whole skill set. They realize how hard it is, and they don't have the discipline to be able to maintain that going forward. So what we're seeing is an increase in rate of hiring. It's happening. Hey, Kyle, good to see you. Welcome on in. Happy Monday. Good to have you here, Kyle. Time to learn to build AI. With Steven, you got it, and the crew. Zergio, that's what we're doing today. We're going to be building AI. So yes, signal internet. Definitely things like DevOps, right? DevOps is great. AI is also great. AI machine learning, maybe some data science. Those are really strong roles that you should get into. Hey, study channel. Good to see you. Welcome on in. Happy to have you here. Hey, Kyle, you're doing some pretty amazing things over there. I saw all the stuff that you sent over the weekend. Pretty good looking. Hi, Steven. Study channel. Good to have you here. The problem is no more creating, it's in sustaining and maintaining. Well, that's 99% of software. Clips, that's 99% of software. It's all about the work to maintain it and expand it and grow it, iterate on it. Photos. Oh, you post some photos you're fixing in general? Oh, check it out. Just have to execute. That's all it is. You gotta build, you gotta do. All right, what do you got over here, Jinlu? Oh, neat. Okay, so you open this up. This is the inside. Well, that's really simple. Okay. There's not much to it. What do you got over here? This is where the broken part was. Oh, no. So you need to... It looks like it's still got good... you don't need it. You just need to add the part back. What was the part? How's it going there, pixelated function? How's it good? Welcome on in. Good to have you here. Happy Monday. If you start with DevOps, do not start with Oracle Cloud. It's horrible. I know, Lemons, don't do that. Exactly, yeah. A USB type B connector. Okay, got it. Hey, Mark Lemon. Good to see you. Welcome on in. Happy Monday. It's Mark Lemon. You got to get your hello. Good to have you here. Like the ones you find on an Arduino Uno. Ah, very nice. What are you doing in the stream? So we are going to go through more Pytorch. So last week we wrapped up our LSTM. I really wanted it to work really well. And you know what? We did! It works so good. Look at the loss on that. So good. Oh, it's what you want to see. You want to see it. You want to see that. So we succeeded there. Now we're going to start walking through transformers a little bit. Just a high level. We will be doing a full series on transformers. And we're going to build a transformer from scratch as well. We will. I made one. It wasn't that good before, but I did. And I want to make a good one. I'll make a good one. So we're going to do a little bit of reading, and we're just going to learn some things. We're going to learn Pytorch, you guys. Thank you for the hundreds in the reactions, and good to have you here. Okay, I can see that. I see those little reaction buttons you click there. Okay, here's what we're going to do. Let's walk on through with some of our code here. And let's see, transformers. Let's walk through it. A multi-purpose network that can take over the state of the art for natural language processing with models like BERT. Models like BERT, you guys. Now that I am with them, I'm staying... Oh, why do they need to redirect me 7 times for auth? Loons. Oh, Oracle. Yes, Oracle Cloud, yeah. For security purposes, right? It's for security purposes. This just has to happen. They're probably using a lot of OAuth is what's going on, and they got code exchanges and things like going on there. Steven, who's the most famous person you met in Silicon Valley or like software engineer industry? Well, there's definitely more famous people than me. I can tell you that. I just have a business and I've been around for a while. CTO at PubNub, raised 134 million. Series E, 1 billion devices on my network. 68 patent claims. Whoops. Click on my name there. And 25 years in tech professionally. So that's me. That's me. All right, let's get through this. All right. A discussion of transformer architecture is beyond the scope of this video. which is the tutorial that we're walking through right now. Pytorch has a transformer class that allows you to define the overall parameters of the transformer model, the number of attention heads, the number of encoder and decoder layers, dropout activation functions. Wow, it's got everything baked in, doesn't it? It's got it all baked in there. You can even build the BERT model from the single class with the right parameters. Ooh, you can build your own BERT model. The transformer class also has classes to encapsulate individual components, like the encoder, the decoder, subcomponents, and the transformer encoder layer and the decoder layer. So you can have the math, and then you can have the weights and parameters. For details, check it out, the documentation. I clicked on this doc, and it's not what you want. It's just a list of methods and functions. Take a look at this list over here. What essentially happened was that you dropped the thing over a year ago while it was plugged in, and it knocked the USB port loose. Oh no, Jinlu. So a year later, you're gonna fix it. Clips was probably asking you for a video idea. Oh, let's see. Oh, I missed your message or Clips. No, like I'm asking who's the most famous you have met. Oh, Steve Souders and Douglas Crockford. Those when they were at Yahoo. I think, is that the most famous? Yeah. That I actually got to talk with for a while and you know, shook their hand and sort of thing. I've met other famous people outside of tech. Those are the best. So yeah, look up Douglas Crockford. Douglas Crockford. Let's see. There you go. Douglas Crockford. The godfather of JavaScript. The godfather of JavaScript, you guys. Why do neither of those names ring a bell to you? Oh, well, because I'm old. They're really old. That's cool. Yeah. American computer programmer Audrey Tang. Let's see, a Douglas Crockford, an American computer programmer who involved in the JavaScript language. Crockford specialized in the form. Have you heard of JSON? Have you heard of JSON? Well, sort of. Douglas Crockford was all about data space versus document space, right? Instead of storing your data in XML, why not store it in JSON? Douglas Crockford made JSON the standard for the internet, all right? That's who Douglas Crockford is. If you ever heard about JSON, you gotta hear about Douglas Crockford. That's cool. These are the founders of programming. Yeah, well, they're luminaries. They're not like the first people to program software. They are prominent figures in engineering for software, for sure. You broke your webcam. Oh, Loons, oh no. And you DIY'd the cable back and it miraculously worked. Hey, that's great to hear. Good job. Yep, San Francisco, you guys. You missed my text? Oh, single intern? What'd you say? Signal intern, what'd you say? You know what? Sometimes it doesn't show through. It doesn't show through, so YouTube will sometimes not show your chat if it thinks it's suspicious. I don't see it. Retype it in, and if it includes a link, it definitely won't show. If it includes a link, it won't show. For sure. Yeah, I don't see your message. Oh, I see your advice. Yeah. Yeah. So we talked about DevOps and AI. You want to so AI is really good. So you are want to move into something real tech, maybe low-level programming or AI. Well, that's what we're doing today. We're doing AI. So I recommend taking a look at what we're building. Uh-oh. Are we still here? Okay, we are. Okay, good. All right, good. There's a little message right here that said it got disconnected, but then it reconnected. So maybe that was part of the picture. I don't know. Resend the text. Oh, let's see here. It's having some issues. Oh, whoa. Oh, I missed all of your texts. Oh, sorry about that, you guys. Okay. I reloaded. You said, can you get any discounts on PubNub? I want to use the right product. Yes, so PubNub is free. It's free forever, right? So take a look at our price. Yes, take a look at this. Okay. PubNub.com/pricing. Pricing. Nope. For pricing. There we go. I wanted to start the plan. Okay, so there's a free plan right here, and it's for 200 users or 1 million transactions, which is more than you need. It's way more than you need. You want to start a starter plan? Check this out. Nice. All right. Sounds good. Clips merge. What'd you say over there? Once you opened your PC to fix something, accidentally let a screw fall in there and it sparked the motherboard. You're supposed to unplug it. You're supposed to unplug your PC when you're working on it. Blue screen whenever you turn on because it was short circuiting. Yeah. Yeah. Hey, John Wiku, good to see you. This dude is exactly who I envision when I think about programmers. Oh, yeah, and making the AI era end of humanity. Oh, ending of humanity. Yep. Uh-huh. Yes, indeed. How's it going over there, Jam? What's up, everyone? Hi, Steven. Good to see you. Welcome on in. Happy Monday. We're going to go through some more Pytorch is what we're going to do today. What was that 404 video? Oh, yeah. That's just the 404 page. Here was it. Let's see. Back. Let's see here. There we go. Pricing. Yep. That's me dancing at our office many years ago. That's me. If you haven't seen it, that's me from many years ago dancing at our office. Please don't end us. Hey, John Wiku, don't worry, John Wiku. The AI is not good enough yet. It's not good enough yet. We don't have to worry about it. We don't have to worry about it. You don't want to learn the code? You like vibe coding. Hey, Tay, that sounds good to me. Hey, let's work together. We can do it. We can build it together. You got some moves, Loons? I know that was back a little while ago. You made an edit of the dance. Oh, you sure did. I remember that, Kyle. That was like many months ago. All right. Enough of me dancing. Okay. Hey, Jacob. Thanks for saying hi again. Good to have you here. Welcome on back. Good you're here. All right. So classes allow you to define. All right. So we just walked through that. All right. Let's walk through more of Pytorch. Data manipulation layers. Let's try it out. Let's get our terminal window up and ready to go. Let's get our terminal ready on to go. Here we go. All right, so we're gonna call this data manipulation, which is pooling, which thank you to Neva, who was here last stream, gave me the full realization of how this works. It's actually really straightforward. We need to recreate this. I know the clips, so we could recreate it. We could. We just need a lot of cameras. Because I had a lot of office cameras, like looking out over the office, and that made it a little bit easier to capture. All right, so data manipulation layers, there are layer types that perform important functions in models, but they don't participate in the learning process themselves. So they do work on the feed forward, but they're not part of the back propagation. I don't think. Well, they need to be, right? Because if you're going to back propagate the output into the input from the previous layer, they need to match. So they are part of the back propagation and in the forward propagation. So, what's up, Mr. Blund? Dylan? Good to see you, Dylan. Welcome on in. Good to have you here. Are you at home or at the office? I'm at home. This is my house. We are at home today, you guys, and every day, because we work from home now. What's your favorite animal in Minecraft? Well, I mean, utility-wise, it's nice to have sheep because you can make beds for the nether and make the beds explode. And then you can get debris, right? Something debris, what was it called? Ancient debris. You can get ancient debris. So Jacob Villages, I think a sheep is a good practical option. However, I'm partial to the cats. They have no function. Well, they do have a function. They keep the creepers away, right? So I do like cats. They keep the creepers away. You guys, I like myself some Minecraft. Don't you get tired of looking at the screen? Because for me, it's annoying to look at the screen after 2 to 3 hours. Is it? You want to just close the screen? Well, I look at the screen for 16 hours. So every day. Lava chicken and arrows? Wait, is that a thing? A lava chicken? What is that? What's a lava chicken? Is that actually a thing? Is that real? Okay. All right, so let's try this out. Max pooling. I actually understand what this is, so we're gonna bring this up here. So Python, we're gonna call this Vim. What do we call this? Pooling.py. Import torch, and then we're gonna say, we'll just call this. We'll call this. We need to give it a name. A. There we go. Jacob Village is Steven. What is your favorite animal? Yeah. It's between a cat and a sheep, right? Because the cats keep the creepers away and the sheep allow you to build beds to make explosives for the nether. It's in the Minecraft movie. Oh, it's a meme. Oh, I didn't know. I haven't seen the Minecraft movie and I should see that. Copper Golem is the most useful. Yeah, I've seen that. Copper Golem can help manage your chests, right? Can manage your inventory, your chest inventory. This music is intense. There we go. Torva. Hey, Torva, welcome on in. Happy Monday. Good to see you here. Welcome on in. All right. Lightning cables are basically just USB cables with proprietary end, right? Are they? You know what? They probably are. I'm kind of curious what that looks like. All right, so tensor dot. Do we want to rand it? Yeah, we want to rand it. Rand 1, 6 by 6. All right. And we get print A. Let's take a peek at this. All right, so Python pool. This will give us a, wait, did I say that right? Torch. Torch. There we go. It's only been 2 days. Can we, let's see if we can make this look better. Let's do this here. So Python pool. So we can read it a little bit more easily. There we go. There you go. Now we can see that a little bit easier. You have multi-cable anyways, if you need it. There's such a thing? There's a thing like that? Let me snip open a random lightning cable. I know, right? That'll tell you what in the truth. Don't do that. I know it's expensive, those lightning cables. How's it going there? Brinks, good to see you. You seem like a smart and social person. I love your energy. Oh, much love from Kenya. Hey, welcome on in. Good to have you here. Yeah, we're doing Pytorch today. We're doing Pytorch. Hey, Mick G Lucky Luke. Thank you for saying hi. Thank you for clicking the hi button. Good to have you here. Oh, by the way, your company makes you work in Directus, and it's so irritating to use the GUI for almost everything. They're pretty rich. How can I get like you? In a terminal? Just use a terminal window. All right, so it's called Ghosty, ghost, tty plus tmux plus vim. That's the answer. Right there. Real easy. Bro, you look like a little bit of Alex Honnold. Yeah, people say that. And they do. They do. That's the wall climber. Yeah. Alex Honnold. A little bit. He's a little bit more, fit. He's a little bit. He does some rock climbing. I don't do that. I type on my keyboard. That's what I do. That's what I do all day. A smidgen. People have been saying that. People can say that. Steven at 5:30. I have to go. Okay. Sounds good, Jacob. Sounds good to me. You prefer Tabby for your terminal? Oh yeah, Tabby could work too. I like Ghosty. Best in the world for climber too. Yep, best in the world. Yep, free climber. Best in the world, free climber. No safety nets. Not a single one. Sounds scary. I thought about that for a second and I got scared just sitting here thinking about it. You used to open all your electronics and mess around with it to see what's even if the thing is just jerry rig everything. Cliffs merge. Well, you got to learn somehow. All right, so here's this. And then if we do a pooled, so B equals torch.maxpool. What is this called? Torch neural network max pool. Torch nn.maxpool 3D. Is it lowercase d? No, 2D. We could do 2D, yeah. Because it's only 2D, right? And then we say 3 on A, right? Can we do that like that? Oh no, that's the layer. Okay, right. Pool equals. Okay. And then we say B equals pool, A. Print B. Right? Is that gonna work? Is that gonna work? Do door? Yeah, there we go. We did it. I'll explain what just happened. Because I understand it. Oh, Steven reminds you of Linus, Sebastian's cousin? Wait, Linus from Linux Tech Tips? Is that Linus from Linus Tech Tips? I don't know what his last name is. It is? Oh, yeah. Okay, well, he's got a beard, right? Linus has a beard. Yeah. Linus got a beard. And he's Canadian, and I'm American. I'm American. So True kind of does look like this cousin. Maybe. Oh, maybe. I don't know. Like Magnus, though, he's fun to watch. Hey, nice. Yeah, Magnus Carlsen, right? Is that the chess champion? We know a few things or two here, you guys. We know a few things or two. How could it be like you? Like this smart? It might sound like a kid, bro, but you're so awesome. Whoa, Signal Internet. I appreciate it. That's a great compliment. I'm pretty sure I read that properly, and I'm going to take it as a compliment. Didn't even know dimensions can be with math. Yes, dimensions are with math. See these here? See these little brackets? These brackets right here? That counts as a dimension. We got ourselves 3 dimensions here, I believe, right? So you've got a vector, which is a 1 dimension, and then you've got the image, which is a 2 dimension, and then you've got the inner dimension, which is a 3rd dimension, which allows you to have a batch, so you can have multiple. Essentially, it's the time series. Sequence of time, you guys. Oh, Magnus Tidbit, the climber. Oh, okay, yeah, I don't know who that is. I didn't know there was someone that was assume. What do you think about OpenRouter? OpenRouter is something for AI to route the different LLMs, route your prompt to different LLMs. Is that right? Is that what OpenRouter is? Let me get that right. See, OpenRouter. Is that right? Is this it here? OpenRouter? Unified interface for LLMs? Yeah, exactly. Okay. So it allows you to one interface every LLM. And they cost money though. They cost 25 free models though. Hey, that's nice. It's a free forever plan. All right. Very nice, you guys. Let's see here. You posted a pic in general. Okay, Jinlo, we'll take a look. What is going to happen with our privacy over the internet? I want your honest opinion. Our privacy? It's getting less private because the governments are requiring you to report your age with verification of identity in order to use certain apps like Discord and things like that. That's something that's coming around. So apparently the governments, they want less privacy. What is it? The UK is also subpoena Apple to say, hey, we need your secret codes in order to decrypt someone's secrecy. And they're asking for it. And Apple's like, mostly no. Mostly no. If Linus were American and a CTO. Exactly. Clips merge. Exactly. Mick G, Lucky Luke, and Claude Code. It includes Claude Code. Okay. You could use it in Claude Code if you wanted to. You could? Could you really? Could you? It was a compliment. Hey, good to hear. All right, that's great. Thank you. It was my translation that was wrong. Oh, Loons. All right, no worries. Understood. All good. Dimensions. You posted in general as well. Okay, Bonzupi. Hey, Bonzupi. Good to see ya. Your phone is your ID. It is. Essentially, it is. Yep. You got your phone right here, you guys. It's your identity. It's now your identity. You interact with chat so much. It's amazing that you're able to get so much done. Top multitasking skills. Yeah. Well, we've been doing this for a little while, and I take that also as a compliment. It's a lot of fun. Streamlink is ready. Oh, right. Thank you, Torva. Thank you for pasting that in. Thank you. I forgot to do that. You can confirm the lightning cables are literally USB cables with proprietary end. Let's take a look. Right here. They're the same. There's the cable right there. You can see. They're basically, yep. I only see a few it's a little blurry right here, but I see like 1, 2, 3, 4. I see 4 cables. Right? I see 4 cables there. I see 4. And basically USB right there. It's a new Mustral. Is there such a thing? Oh, and right. Oh, up here, right. That's right. Mr. Vibe. Yep, exactly. You get a little cat avatar right there. We need privacy, not because we are criminals, but because we don't want to be cheap products in the hands over to the governments and the tech lords. Yep. All your data is belong to them. All your data, it belongs to them. It sure does. Okay. Even the Indian government has a policy that they tell YouTube to ask to take the video down if they have to take it down in 3 hours, no questions asked. And at the end of the day, we now have the power that, oh, clips merge, really? Oh, that's crazy. That's scary. We're in a whole new world now. We are. AI's everywhere, you guys. And our privacy, who knows? What's it going to be like? I think we're going to see very slow change when it comes to that. Very slow change is my thinking of that. Let's see. No one's going to believe. They have noticed that whenever you get on some e-commerce site, even though, oh right, you didn't share your number with them, that actually starts with sending you marketing things in your WhatsApp. Oh, yep, they're all connected. They are. It's a whole network of connection. They can see where you are, where you went, what websites you went to, and you become their target because now you are an identified purchaser, right? You've bought before, you will buy again. If that Steve Jobs were alive to do, you think Apple would be different? Yes, I think so. Because we've kind of taken the iPhone to the max step, right? And wouldn't we see something? They tried to evolve, right? What is it? The Apple VR headset. And they're trying to do Apple glasses, and they've got the Apple Watch. They're trying new form factors, but the phone and the tablet, mostly the phone, is still pretty predominant. If you understand software, Steven, you can build your own architecture where you control the rules. That's true, Kyle. You can make your own decisions, you guys. Okay, let's go through this real quick. So what we see here on screen is we've created a pool layer. This pool layer is going to only extract sort of what you call the highlight of the segment that you're currently scanning. In our case, we said we wanted a 3x3 grid. I believe you could say 3x3 like this, and it's the same thing. Let me see if it's exactly the same. I'm pretty sure it is. It's identical. Yep, it is. It's identical. Let me confirm. It is 1, 2, 3, 1, 2, 3. No, that's something different. No. It's the thing. Okay, it is. All right. Okay. So take a look at here. You're gonna see something interesting. The max pool means to select within a 3x3 grid. Select the maximum value. That's all it means. Isn't that crazy? Isn't that crazy? You would think max pool 2D 3x3 sounds like it's pretty powerful and impactful. It seems amazing. A max pool. What is that? All it does is it takes the maximum value in a 3x3 window over your data in your tensor. And that's it right there. You can see it right here. So here, I'm gonna try to take a screenshot of this and I'll show you. We'll walk through it here. We'll go into, I think we can we paste it here? Yes, we can, okay. So take a look at this. So we see here a bunch of tensors. And if we grab here, we're gonna look at our window. It's gonna be a 3x3 window. So we're gonna snag these and we're gonna look in this 3x3 window and we're gonna find the largest value. And then we're gonna use that as the output. And we're gonna do the same thing for the next one. What's the largest value in this 3x3 over here? Let's take a look, you guys. The largest value in this 3x3 appears to be 8967. And what do you see right here? I see a little bit of 8967 right here. Sure do. And if we look for the max value in these three, we're gonna see 7540, right? C7540, and we should see 9839 in this three right here. Let's take a look here. We should, right? There it is. Right here, 9839. That's all a max pool 2D is. That's all it is. Isn't that crazy? Real-time communication network, send and receive messages very fast. You got it. Hey, Dylan. That's what it is. That's what PubNub is. You got it. Loons, thank you. Thank you for mentioning. Thank you for mentioning. When the product is free, know your data's the price. That's right. When the product is free, your data, your privacy, all the price. So PubNub allows you to deliver live interactivity that your users are looking for. The top 10 apps in the App Store all have built-in app communication. Things like chat, multiplayer gaming, collaboration, hearts, emoji reactions, delivery, transportation, gaming, right? This is everything that we do. We power the top apps in the world for telemedicine, healthcare, e-commerce, livestock quote, bid updates, fintech with securities updates, right? When the price change, when the price go up, the market price, the market rate, and call centers with support tickets. And when your car, you see your car on the map, and that car just happens to be carrying your lunch, which is going to be a burrito, and it's going to be on its way in 20 minutes. It's going to be there pretty soon. Like a multiplayer game, exactly, Loons. Messaging, you got it. It's messaging in an app. Wait, I was wrong. Data minus is actually white and data plus is green. Okay, Jinlu, got it. Got it. That's where the data comes in. And so the white and green, got it. 6, 7, 6, 7. By the way, on the USB cable, got it. We figured out the USB cable. Chipotle, exactly, Chipotle. Chipotle's on its way, you guys. It's lunchtime. Where is it on the map? So many very amazing things. I'm so excited. We're going to be doing we're going to be doing a little bit of longer streams going forward in the future, and some more in-depth building of some future technology in about a week or so. Maybe 2 weeks, maybe in 2 weeks. We're going to do some fun things, you guys. You should do a meet and greet someday. Oh yeah, Clips Merge. I like staying inside. I don't want to go outside. You want me to go outside? You have my attention? Flip with Kyle? Yes. All right, so Kyle, guess what? Kyle, we are building some new technology that we are going to release in a couple weeks. Actually, we're probably going to release it a little bit before that, but we're not going to talk about it until we get a few beta testers. We're hermits here. Me too. We're all hermits. Let's stay inside where it's safe and warm. Right? Safe and warm and climate controlled. And we got our fridge, right? We got a refrigerator and a couch with a blanket. Ian meet and greet. Oh, Ian. Wait. Torva. Wait, Ian? Are you talking about Ian Jennings? Torva, wait. My brain doesn't... Oh, Lan. Oh, got it. Okay. You're not talking about someone I thought you knew. Okay, never mind. Okay. You're going to solder that USB cable directly to the board instead of buying a new USB thing. Hey, Jinlu. Show us it. Show us when you do it. It's very rare that a developer touches grass. I know, right, Loons? There's grass. If I look out my window, I would see grass. I would. However, it's outdoor material. We're not going outside. Can't go a day without touching grass. Okay. It's understandable. If you get used to it, you kind of want to keep it. Oh, Steven and I had a question about selling software. Basically, I made software that uses data from the IVG, basically the government office responsible for managing public bus transit. Oh, now the software uses that data that it's usually just used to display delays, and you made it so the position is estimated on a map now. You want to do like a presentation? You want to present it. You mean you can send it to them, but how do you do that? Among to likely sell it and just send, hey, you made this prototype. What if you want to buy it from me? Oh, Torva, okay. So that may happen, that may be possible, though it is rare. Let's talk about that. Okay, you guys, strap in. You're building an app and you want to sell the app, right? You might want to sell it to a company that would find it valuable. That sounds like a really perfect deal, right? It sounds like an amazing opportunity. However, that doesn't usually happen. What companies usually buy are one of two things. They either want to buy users to get the user base and monetize the user base, or they want to buy revenue, right? And in other cases where those two things might not be present, they might want to buy the team, so the software engineers or the team that's building. They think the team's really smart and they want to use that team's knowledge to go further with whatever ambitions they have. So it's usually the first two. Acquire users, acquire revenue, or acquire the team. Usually it's the first two. nobody wants to buy an app, especially now that they can just auto-generate the app in a matter of hours. So I'm just letting you know, that's kind of how it works. You're so locked into this, make it total sense. I know, right? Got it. Users or revenue. And so that's what you got to do if you want to if you want to, like, have an exit. Now here's the difficult thing. You're using their data and infrastructure, and since the data you would use it is owned and protected by that agency, what should I do? If it's protected and you can't release it to the public and you can't get users, you're kind of stuck, right? Aren't you stuck? Is there anything you can do? Well, you might be able to license the data from them, right? You might be able to license the data and say, hey, I want to license this data and I need to pay for the servers and the cost of this. So I need to work with you to figure out a model that I can use. Maybe they can license it to you for free. You mean, can I sell the concept or usually no. Usually you can't sell the concept. I know it sounds like such a disappointing thing. You wouldn't even be great if you could build an app and then sell the app. I know it sounds like the most amazing thing. Now, especially with the ability to generate AI, everything's throwaway. So it's even more difficult now than it was before. It was. Ahmad, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're focusing a lot on AI these days, aren't we? EI by Game Studio kills it and adds microtransactions and steals the team. Exactly. Cash grab. Exactly. Loons, you called it. That's what it is. You called it. All right, so that's what a max pool layer is, you guys. Isn't that amazing? So that's how that works. It seems like it would be something so magnificent for someone to give it the name Max Pool 2D. Doesn't that sound like it should be something worthwhile in an algorithm? However, it is just so simple. It is just so simple. The maximum value in whatever window grid you give it. Isn't that silly? Isn't it silly? And if you want, though, you can change the step. I believe you can change the step. Step equals 2. Can you do that? I think you might be able to. All right. So how do we do that? How do we do that? All right. We need to ask the AI real quick. Let's ask the AI. All right. So Gemini. All right. Let's open up Gemini. I like using Gemini on stream. All right. Okay. How to specify step in Max Pool 2D Pytorch. What is the parameter? So I gotta go, Loon. Sounds good. Good to have you here. All right, unless you make changes, something specific, it would be cringe to copy it. Kyle. Yeah, you got it. What to do, since preferably you want to sell to that agency, so both the everyday life of everyone would improve and you don't have the hassle with the government data. The only thing that I can recommend is that you need to reach out to someone. You need to reach out. Why is it asking to read a file? No. Stride. It's called Stride. Okay. I just wanted to submit a question. I didn't want it to actually do the work for me. I want to do the work. It's called Stride. There you go, you guys. Now we're going to get a bigger output. We should. Stride 1. How about Stride 1? Is that better? Yeah, now we get the bigger output. Okay. So now what you're going to see is, you're going to see a 3x3. So let's highlight this 3x3. And it's only going to step one range at a time. So 3x3. And it's going to grab 9516, right? 916, right? 9916, because it's a new one, right? And then it's going to go boom, boom, and it's going to stride 1. So the second number should still be 9916. Then we're going to stride again by 1, right? The next biggest number appears to be 9763. Yep, there you go. Stride of 1. Max pool. So there's a little bit of neatness to the max pool function, right? There's a smidgen of neatness. Just a smidgen. You think it's trying to edit your code? It did. It tried to edit. I'm like, nah. I only wanted the answer. I didn't want you to edit. HS, good to see you. Thank you for clicking the hi button. Happy Monday. you try asking, how do I do this? And it just does the thing for me, even though I wasn't asking. I know, yeah. And it figured out what file I was dealing with too. Yeah. So I said, no. I only want to read it. I only want to read it. So that's Max Pool 2D, you guys. Pretty neat, right? I think it's pretty neat. However, it was very misleading. It feels intimidating, right? You look at this code right here. You're like, wait a second. I don't know what that does. It's intimidating. Hey, Tech Ed, good to see you. Thank you for saying hello. Welcome on in. Happy Monday. If you look closely at the values above, you'll see that each of the values in the max pooled output is the maximum value in each quadrant of the 6x6 input. See, that's what I told you. Normalizing layers, recenter and normalize the output of one layer before feeding it into another. Centering and scaling the intermediate tensors has a number of beneficial effects, such as letting you use higher learning rates without exploding or vanishing your gradients, so you can train the model faster. That's amazing. So let's do some batch norming, you guys. I've not done this before, and I've never really needed to norm my batches. Have you guys? I'm curious to see what this is going to look like. Why'd they do some math on this? Oh, just to make the numbers look bigger. Okay. We can do that. We can do that too. We can do that. All right. Let's do this. Whoa. Where'd that go? Where'd it go? Hold on. Did we click on something wrong? Yes, we did. We clicked on something. Happy Monday. Love the Python coding and Rust. Hey, yeah, there we go. One of the really good languages, right? We got some Python in there and Rust, you guys, and Rust. Bonzupi, you're back. I had to find your birds. Oh, what are the birds? They were hiding in the backyard. You have birds? Do you have birds? Or are they friendly birds? Are they inside birds? Do they go inside or are they outside birds? All right, so we're gonna do a torch rand, then we're gonna do a torch neural network BatchNorm 1D. Okay, let's take a look. Norm tensor.mean. You don't need to do the mean. Why would you do the mean? You don't need to do the mean there. Man, you're scary. Oh, Zom, let's say your name right there. Well, thank you. Yes, they're friendly birds, and they live outside. Nice. 4 chickens and 2 guineas. Guinea. I don't know what a guinea fowl. What is that? What is a guinea fowl? We're gonna find out, you guys. Let's look at this. What is that? Some sort of bird. I don't know. It kind of looks like a pheasant, but not really. It's like a chicken. It's kind of like a chicken. Huh. You mentioned normalization. Does the function use? Yes. So we are going to look at some batch normalization there. Hey, Max B49, thank you for subscribing. Welcome on in. Happy to have you here. Happy Monday. Welcome on in. We're doing some AI today, you guys. We're doing some AI. How do you decide between writing a custom layer versus the built-in module? So you want to use the built-in as much as possible because it's going to reduce the amount of code that you have to deal with. You want to write your own if you're doing something state-of-the-art, maybe. If you're exceed, or if you're learning. This is what we're doing. We are learning the framework. We've been writing AI for a few years now, and we want to be able to learn the framework. We're becoming Pytorch experts. That's what we're doing. How I wasn't subbed. I've been watching for almost 2 weeks straight. You just subscribed. Jane, well, thank you. Thank you for subscribing. Good to have you here. You're subscribed now. I just saw it. See it show up there on the screen. How do you decide between, let's see, Google them and they're adorable. They're related to chickens. Yeah, they are, Bonzupi. They sure are. Do we leave it open? No, here we go. Nope. Oh, right there. Yeah. They look chicken-like. They do look like chickens. All right, let's keep going. So let's do some batch normalization. All right, BatchNorm 1D. BatchNorm 1D. B-A-T-C-H norm 1D. All right, we should be able to do that. Vi norm norm.py import torch a equals torch.rand 1 4 comma 4, and they wanted us to multiply by 20 and add 5, and we're going to see norm equals the torch.nn batch norm 2D And then, was there anything there? Yeah, 4. Okay, so there's a 4. I don't know what a 4 is. We're going to find out. We're going to mess around with it. We're going to play with the numbers, you guys. And then we're going to say print A. And we're going to be B equals norm A. And we're going to print B. And there we go. That should give us the data that we're looking for. Now let's start messing around with it. Here we go. Yes, please. Python. Oh, I forgot to turn on the. You're seeing. I didn't realize this, but I forgot to turn on the fancy keyboard here. You've been looking at my desktop the whole time. Good thing there's nothing to worry about on that. Okay. Guinea fowl are very noisy and neurotic birds. They start squawking anytime something happens dangerous in the yard, like a dog or a leaf. Even a leaf. There we go. So I messed that up somehow. How did we mess that up? It should be pretty straightforward. A print B norm. Where'd we mess it up at? We're gonna find out there. My tensor.mean. My tensor. Norm layer tensor. Right there. That's it. We didn't do anything wrong. We typed it correctly. Is this wrong? All right, let me copy and paste this to see. Let's see if we did anything wrong here. All right, paste that. All right. Torch.rand. We'll print that out. That part looks fine. We're good to go there. We don't need to deal with that. I don't think, right? Or do we? Do we need to do that? Is this something that we have to do? I don't think so, right? I really don't think so. That's just gonna do nothing. It's just gonna output a new tensor. It's not necessary. It doesn't do anything, right? Print a.mean. Right? That's not gonna do anything. Yeah, I told you. It's just gonna create a new tensor that's the average of all of your other values inside your tensor. Oh, it updates the mean and variance for each batch. Is that what that does? HS? So let's read. All right. Normalization layers recenter and normalize the output of the one layer preceding it, feeding it into another. Centering and scaling the intermediate tensors has a number of beneficial effects, such as letting you use a higher learning rate because it's shrinking the data. Or is it? What's going on here? We are going to find out. Oh, okay. Well, that's kind of what a softmax is, right? What's the difference between a BatchNorm and a softmax? Do you guys know? What's the difference? All right, let's get some help here. All right, let's talk to the AI real quick. Gemini. All right, so letting it load. Gemini, what is different? How about this? Difference between a BatchNorm and softmax, right? Because they're pretty similar. They've reduced exploding gradients. Running the above call, we've added a large scaling factor. Yep, so that's why they did this multiplication stuff here. They wanted to make that model. They wanted to make all the values very big. They made them very big, right? We've added a large scaling factor that offset to an input tensor. You should see the input tensor's mean, which is going to be very high. It's 16, right? I've decided that you're just going to buy a replacement USB. What? Oh, it didn't work. Jinlu, did it not work? It seems like you should be able to solder that on there, right? Or could you? Would you? I don't know. It seems like you should be able to. There's only 4 wires. You should be able to make that work. Somewhere in the neighborhood of 15. After running it through the normalization layer, you can see that the values are smaller and grouped by around 0. In fact, the mean should be less than 8. Oh wow, it should be very low. Oh, the mean should be it is very low. It's a very low mean. Because it recenters it around 0. That's why the negatives are there. That's why. Oh. Okay. So there is a difference between BatchNorm and Softmax. We're learning new things, you guys. The wires were too thick. They didn't look that thick. They look like they would fit perfectly fine. They actually look less, they don't look thick enough. They look like they're too thin. Softmax has output probabilities. Yes, however, the output probability is identical whether you Softmax it or not. Right? That's one of my pet peeves when I see Softmax on the attention heads. I'm like, it makes sense if you're going to be using it for the middle of your model or somewhere in the middle of your model. For the output layer though, you don't ever need Softmax because you can just find the argmax value of whatever your token is. You don't need it. Hey, how's it going there, Sigma Edits? Good to see you. Hey man, how are you? We're doing really good. Thank you for asking. Happy Monday. We're doing some Pytorch, you guys. We're learning about some batch normalization right here. Let's see what our AI came back with and said. Okay, we got ourselves some little bit of difference. We figured it out though. We figured it out. All right. Training stability. This is batch norming. It normalizes the input layers and it has a mean of 0, around the variance of 1 across the batch. This prevents the gradients from vanishing or exploding and allows for a higher learning rate. So you can increase that learning rate and just burn. You burn through it much faster. For each feature, it calculates the mean and standard deviation over the current batch. That's really easy, and then applies a learnable scale factor, which is gamma, and shift beta, which is going to be some sort of value. So it allows you to shrink the value and then shift them down, right? So you're going to shrink the numbers, make them between 0 and 1, or -1 to +1, right? And it's going to bring a beta shift, so that way it centers around 0. Then it applies a learnable, used inside the network, typically between layers, the linear layer and the convolution layer as its activation function. That's amazing. That's amazing. I like that. Is that Claude Code? This is Gemini. Bonzupi, this is Gemini. They aren't that thick. Oh, but they're still too thick apparently. Are they really? All right. Okay. Softmax. Purpose. Output interpretation. You don't need it for the output though. You really don't. It squashes over the vector of raw scores, logits, right? Into a probability distribution where every value is between 0 and 1. And the entire vector sums to 1. Yeah, perfectly fine. However, what do you need it for? Maybe if you're training the model and you want to target the output and you want to train it, yes. During training, for sure, you want to use your Softmax. You do. However, for inference, you can throw it away. You could throw it away. How it works, calculates xi, it's giving me some sort of pretty equation that's not printing on the terminal, for each element in the input vector. Yeah, it's finding the average and then creating a beta and a gamma. Okay. Used at the very end of classification network to produce the final. Oh, that's for BatchNorm, but Softmax is different. Locations used at the very end of classification network. It's not. No, you can use it before that. You don't have to use it at the very end. You can use it in the middle. All right, so there's some hallucination here. Speeding up and stabilizing training for BatchNorm 1D. Right, I like that. That's pretty great. Right here. Let's go BatchNorm 1D right here. That's what we're looking at right now. Across the batch, it does it across the batch, which is pretty. That's why it's called BatchNorm. Hey, we figured it out. Okay, BatchNorm. That's great. Yes, weights and biases for scaling and shifting hidden layers in deep neural networks. And then Softmax, let's kind of read this one right here. Convert scores for probabilities across the features and classes horizontally, not vertically. No fixed mathematical formula. Yeah, there is. There's a fixed mathematical formula. There certainly is. Final layer for multi-class classification, and you can use it before the final layer too. In fact, that's what transformers do. I've got proof. I've got proof. We can even call the AI out on it right now. All right. All right. So here, what about transformers, which is tension layer, has Softmax in middle of model, right? All right, let's see what it says. Let's see if we got the AI. Let's see if we fixed something. Yes, you're exactly right. Oh, I mean, it's always going to say that. But I know I'm right because I've seen it. The attention. I know what this algorithm is. I've used it many times before. I've used it. I've used the Softmax in the attention layer. In a transformer, the scale.product attention calculates how much focus on one part of the sequence it should to give it another. It does this with Softmax. Yeah, right there. Right in the middle of the model. It's like you can only use this for the output of the model. No, you can use it there too. It's crazy, you guys. Do you think AI is the best way to learn programming because you can basically give your specific requirements for learning? I think it's a really useful tool to search. So if you want to learn, you can use it as a search engine like you would Google and Stack Overflow. And that's kind of what we're doing right now. Whenever I need an answer and I don't want to just go find it in the docs and read it manually, let's just ask the AI. However, you just saw right here, it gives you false information. Ahmad, good to see you. Welcome on in. Happy Monday. Good to see you. We're doing some Pytorch. So is that 2 ways for training AI models? There's more than 2. Let's just put it. There's a few more than 2. Ahmad, good to see you. Welcome on in. All right, so let's see if we can get this BatchNorm actually working. So did we type it wrong? What's the problem? Expected a 4D input, got a 3D input. Yeah, it is a 3D input. Did we do it wrong? We didn't do it wrong. We did it correctly. Oh, is this because of the 4? So is this the broken? This is broken right here. It needs to be 3, right? So we found another bug in the tutorial. Yeah? We found another bug in the tutorial? No, okay. Expect a 4D, got a 3D input. Let's bring it down to 2 then, maybe? 40, it still wants 40. Is it 1D? Oh, it's not, it's me. It was me, you guys. It was Steven typing. Darn it. Oh, it's still not working though. Do you like innovators? Ahmad, I sure do. Are you an innovator? Your favorite way of training LLMs is writing the probabilities manually for every parameter. Oh, Jay, there's only a few billion parameters you got to do that for. How long would that take you? Do you use pen and paper? Do you use a spreadsheet? I'm curious about that. I know you're joking. I know you're joking. Don't get me wrong. I know you're joking. Soon we'll be publishing a new concept of AI. Ahmad, I think so. It happens. We make evolving algorithms, and I kind of want to be there as part of it. I think it sounds like a lot of fun. Let's evolve AI together, you guys. Let's do it. Right now we have really smart autocomplete engines. They predict the next token, and they do a very good job. They're optimized for very specific tasks like writing code or making pretty images. Can we do better? I don't know. We're gonna find out. We just gotta learn a few things first. Okay, so it's still broken though. Why does it want this? Running mean should contain 4 elements, not 3. 4, okay. Because it's got 4. Okay, so it's a 4x4 here. Okay, there we go. All right, so let's do a softmax on that as well. Soft equals torch.nn.softmax, and we will do a let's see, a C equals soft on A. And we'll print C. So we're going to see a little bit of different scaling here. Whoa, no. What? No, something's wrong there. We got a problem. Dim equals 1. Let's try that. There we go. Much better. A smidgen better now. Can we do bin 2? I think we have to do dim 1. What if we did 3? He's going to let me. I didn't think 2 was going to work. Yeah, I didn't think so. Okay, so let's go back to 1. Okay, so our softmax gave us some nice, pretty numbers spread evenly. A nice, even spread there. Turbo quant. Oh, Sigma edits. Have you needed to write a custom autograd function yet? I have not needed to write a custom autograd function. And most of all the math is already there. You just copy and paste all the algorithms. I've done it before, but I've never needed to. Let's just put it that way. I have definitely written my own. I've never needed to. It's not been mandatory. It was all pure educational. see. We almost achieved 75% of control. Once successful, you will run 22 billion parameter from cell phone even. Oh, yeah. It's going to happen in our lifetime. We're getting it. We want bigger and bigger, right? We want more and more. We need more transistors. Faster, faster, faster. It needs to happen, you guys. All right. So let's keep on going here. We are looking at our batch norm, which I completely understand now, and it makes me happy. However, I feel like if you're properly using activations, you might not necessarily need this, though it is interesting. It is an interesting activation function. Do you think BatchNorm 1D would count as an activation function? Is that the case? Let's do this, is BatchNorm 1D is activation function? Let's see if we get it. It'll figure it out. It'll figure it out, even though I typed it wrong. No, don't read any files. I just need to run this in an empty directory is what I got to do. I got to read an empty directory. All right. No, it says no. It said no. Hold on. Oops. Did I close that? I didn't mean to. Is it gone? Oh, it's gone. All right. All right. Let's here. So mkdir empty, cd empty, Gemini. There we go. Bros coding GTA 6. I know, Jack Attack. Good to see you. Welcome on in. All right. So batch norm 1D is like can be used as activation function, question mark. No, do the resume thing. Oh, the resume thing. Oh, it gives you a resume command when you close the Gemini. I missed it. Okay, we'll have to do that next time. Jinlu, thank you. I've seen that on Claude Code. Jinlu, thank you. We'll have to do that next time. Okay. So where are we here? So that was our batch norm. And it looks like it needs to know. What if we did 5 here? What if we did 5 by 5? Curious to see if that will work. It doesn't, because it wants 5. You need to define exactly. You have to define exactly what your target output is. Okay. Ahead of time. Why can't it just know? It should just know. Right? Can we do 3? Can we do less? I don't think we can. No. Can we do more? Can we say 6? Or it needs to be exact. Yeah, it's got to be exact. Okay. That makes sense. Okay. The more we know. See, Softmax doesn't have a problem, although it does want the which dimension that you're looking at targeting for that. Okay. Let's go back over here. Okay, so no, batch norm cannot be used as an activation function in neural networks. Those two components are serve different purposes. Activation functions like rel use sigma tend to introduce non-linearity into the model, allowing it to learn non-linear patterns. Batch norm, however, isn't that. It's something different. Normalization layer. It's a normalization layer. Okay, that stabilizes and accelerates training by ensuring the inputs in the next layer have a consistent mean and variance. So it centers around 0 and it's averaged across all of your outputs. Okay. Data hoarders. How's it going there, data hoarders? Your name's Data and it's pronounced Fa? Oh. Wait. I see what you're trying to do there. You almost got me to say it. You almost got me there, data hoarders. All right. It took me a little while to figure that out. While both layers are in a neural network, batch performs linear transformation scaling. It's not non-linear, right? It's linear. Batch is linear. Does not provide any non-linearity requiring for a deep neural network to function. Data hoarders. I see what you're trying to do there. Okay. You found a new way to force AI to write good Rust code. Did you, Bonzupi? Tell us. Let us know. What'd you figure it out? So I'm going to do the mean on that really quick so we can, just so I remember. So let's do print print b dot mean. Click here, and then we'll do c dot mean as well. Might as well. And c dot mean should be 1, right? This should be equal to 1. And this should also be roughly equal to 1. Around 1, right? This a dot mean will be like 15, right? So we got 15, 1, and 1. Let's see if we do that. Let's see if we get that right. I'm gonna print them all at the bottom here, so it's a little bit easier to see. Here we go. So B is 1. There we go. There we go. This is my guess. I think we're going to see something like this. It should be close to, but not exactly 15. And 1 and 1. I think, right? Or is it 0? Wait. 0. It should be close to 0. So the mean should be very close to 0, which is going to be like a very, very big... It's going to say like 1e negative 8 or something like that. Right? It's going to be around there. Let's see. Forbid it to using the compiler, checks its work and instruct it to only write code that it can verify will compile. Oh, it can't use the compiler? That seems like a really nice crutch. If it can't determine that the code will compile just by reading it, it's probably overly complex. Oh, then it will simplify it. Hey, Bonzoopi, good idea. You haven't seen unwrap or accept in days? Nice. That's really good, right? Because it covers all the cases. You got to make sure that no unwraps in production, no unsafe, right? No expects. Okay, let's see if we get it right here. We get 15, 0, and 0.2. 0.2 is not correct. It should be 0.1. It should be 1. It's still 0.2. It should be, oh no, it is 0.2 because everything adds up to 1. We need to say sum. We do sum here, it should be 1. 50, what? 5? No, oh wait, because I did this here. I did it wrong here. I'm gonna, 1 now, 1. Still 5, what are you talking about? 5, come on, what, 5? Are you serious? 5, no. This is messed up. This is correct. So I got these right. It's just that this Softmax is not doing what I thought it was gonna do. You think you're gonna try and go to bed now? All right, Jinlu, have a good night. Sounds good, Jinlu. We'll see you next time. Good to have you here. Thank you for sharing your USB adventures. All right, let's keep going. This is supposed to be 1. Mean. See what the average is. The average, I assume, should be 0.5 is what the average would be. 0.5, because it's halfway between 0 and 1. The sum should be... Why is the sum not 1? Here, let's do this. We'll do C... We'll make it easy. Like that. C mean. And then B mean. Okay. So, A mean 15, B mean is close to 0, C mean is 5. Why is it 5? Like, what's going on there? Did I mess it up? I feel like I couldn't have. And then C mean is 0.2, which I thought was supposed to be 0.5. Something's weird. Something's weird. Something's weird, you guys. What's broken? Something's broken. What is the deal? What could it possibly be? All right. Let's take a look. Okay. So our output C is right here. That's our softmax. And all these things added together. Oh, wait, maybe we have to do this differently. Maybe we have to say dim equals 1, like this. Let's try that. There we go. Okay. I see what's going on now. that's why 5, because there's 5 layers and it's summing over all 5. So let's do dim 2. So it's 5 on purpose. Okay. Because when it sums it, it's doing everything as a batch. It's like batching. It is in batch format. That's why. Okay. So if we didn't have this batch here, then it would have been what I thought it was. Okay. Let's try that again. So now I've solved this riddle. And then the average for each of these in C, it says 0.2, but if you add them all up, it's going to be 1. Right? 2, 4, 6, 8, 10. So that's what the answer is there. Mean, and we say dot sum. Let's try that. Now it's going to be 1. There it is. That's the answer. We figured it out. Okay. On to the next phase. Dropout. We're going to do dropout now. Okay. So we just had fun here walking through these batch normalization. I also took a look at the average across that, and we did Softmax to compare it with Softmax to see what the difference is. Softmax has apparently some nonlinearity to it, which allows it to be considered an activation function. Running the cell above, we've added a large scaling factor and offset to the input tensor. You should see the mean, yep, exactly. Somewhere in the neighborhood of 15. We read this already. After you're running through it, the normalization layer, you can see that the values are smaller and grouped by around 0. In fact, the mean should be some very small number very close to 0. And it is. It sure is. This is beneficial. And we discussed this already because it's strongest gradients near 0. Sometimes suffer from vanishing or exploding gradients for inputs that drive them far away from 0. Keeping the data centered around that area of the steepest gradient will tend to mean faster, better learning, and higher feasible learning rates. So you can increase your learning rate, which allows you to train faster on your model, and you apparently get good results from that. So it's an acceleration technique. Dropout layers. All right, now we're going to do a dropout layer. Have you guys ever done dropout before? We're going to figure out what that is. I've done it before myself many times, and I've written my own because they're the easiest to write. They're the easiest. Basically, they remove data. They remove data from your output on your model. They hide data. They throw a mask, and it's random. It randomly masks data. So that way, it's kind of neat because it allows your model to attend to very specific portions that it's being trained on at that moment in time and ignore everything else. So it can actually improve your model. It's a form of normalization, regularization, I think, right? Tools for encouraging sparse representations in your model. So that way you can randomly run into a sparse pattern and find those and then add that information into your model weights. It's pushing to do inference with less data. Oh, inferencing. Okay. Interesting. Dropout layers work by randomly setting pairs of the input tensor during training. Dropout layers are always turned off for inference because you need to get all your output on inference. Just for training though, it allows you to ignore certain things. So it's pretty neat. This forces the model to learn against this mask and reduce data set. All right, let's try it out. N dot and then the probability. P equals for probability. Okay. Dropout.py. Import dot torch. We're going to say A equals torch.rand 1, 4, 4. Okay, and then we're going to say what do we need to do there? Dropout, do we say drop equals torch.nn.dropout? We're going to say the probability is, we're going to put it to 50%, which is 0.5. Print A, and then print dropout A. Python dropout. There we go. Spell Python correctly. Python, there we go. Okay, so what we see here is we've got what we'd see is maybe the output from a layer in our model, some output of layer in our model, represented as A here. And then when we apply a dropout to it, it's going to randomly select any of these parameters or the coefficients here to 0. And it's going to do that to 50% of them. I see a lot, though. It feels like that's more than 50%. So there are 4 by 4, which is 16. How many zeros do we see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a little bit more than 50%, right? Let's try it again. 1, 2, 3, 4, 5, 6, 7. Okay, so it's up to around 50%. So now this is even more. 1, 2, 3, 4. So that's 12 zeros. Why is that so heavy? Let's do 10%. It's a probability of, okay. That makes more sense now. It's not a perfect number. It's not a distribution. It's not going to perfectly assign a value. It's not going to say it. That's what we're going to see there. Okay. So it's a probability, a 10% chance that it's going to drop to 0. That's why. Okay. It makes sense now. So if we say a 50% chance, that means we should see around half of them. However, it can go more because it's a dice roll for every single parameter if it's going to be masked out, right? In this case, it did 1, 2, 3, 4, 5 zeros out of 16. That's dropout. The above, you can see the effect of dropout on a sample tensor. You can use the optional p argument to set the probability of individual weights dropping out. If you don't do it, defaults to 5, so 50%, which is what we even chose here as a probability. We know right there. 50% is pretty high though. Okay. So we could walk through activation functions and loss functions. Let's just we'll read over these really quick because we don't want to miss anything. Let's see if we derive any value out of this because we're already pretty familiar with activation functions and loss functions. An activation function makes deep learning possible. Oh, you can't do deep learning without activation functions. Impossible otherwise. A neural network is really a program with many parameters that simulates mathematical function. If we did as if all we did was multiply tensors, have multiple tensors by layer weights repeatedly, we could only simulate linear functions, just the linear ones. Further, there would be no point to having many layers, as the whole network would reduce. It could be reduced to a single matrix multiplication. Hold on. So let's read this like little pass here, right here. As the whole network would reduce, could be reduced. See, there's a typo here, I think there's a typo. As the whole network would reduce, could be reduced to a single matrix multiplication. So we found a typo, you guys. We can add that right there. Is this... whatever. There's a way to report this because I believe the hackathon started, right? The Pytorch hackathon started. We should be able to do that. Let's see. Was it called? What was the Pytorch hackathon called? So Pytorch hackathon. It's Docathon. It's called a Docathon 2026. 2026. Yes. Here we go. Let's take a look here. Okay. A community-driven hackathon. Yeah. Oh, it's not yet. Okay, it doesn't start until May. Okay. So we can submit in May. It kicks off. So in about a half a month or so. About a half the month. All right. La 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 la. Inserting nonlinear activation functions between layers is what allows a deep learning model to simulate any function rather than just the linear ones. Module has objects encapsulating all the major activation functions, including ReLU and its many variants, TANH, which is my favorite. I like TANH. Hard TANH, sigmoid, and more. It includes other functions such as Softmax, which we've been using today, that are the most useful for the output stage of the model. Loss function tells us how far the model's prediction is from the correct answer. This is the error, right? Pytorch contains a variety of loss functions, including MSE, one of my earliest, the first one I wrote. Mean squared error is equal to L2 norm, is it? Cross entropy loss Negative likelihood loss, negative log likelihood loss, right? Useful for classifiers and others. There we go. Total running time of script. I think it's a little bit more than that. All right. Where are we here? All right, so before we start, we need to run our tutorial. So let's get into Pytorch Torchboard, right? TensorBoard. We'll get an early start on this. So this is the plan for tomorrow. We're going to do more TensorBoard tomorrow. I think it's a good plan for tomorrow. Okay. Conda install Pytorch Vision. Do we already have this installed? I don't even have Conda installed. We can do it through pip though. Okay. There we go. Okay. Installed. Introduction. In this notebook, we'll be training variants on the Linnet 5 against Fashion MNIST. Fashion MNIST is a set of images that it's a bunch of clothing and like purses and boots and things like that. All right, so TensorBoard. I've never used this before. Let's take a look and see how this works. All right, so let's type this out. We're gonna type it out by hand because we want to learn this. All right, so TensorBoard tutorial. NN import torch dot, what else you want? You want functional and optim. NN dot functional as F and import torch dot optim for optimizer. And then we want torch vision and torch vision transforms. Okay. Import torch vision. What else do we want? Matplotlib. Wait, oh, no. Why are we getting Matplotlib? We're trying to use TensorBoard here. All right, pyplot and NumPy. Matplotlib, pyplot as PLT, and import NumPy as NP. See, you don't, with TensorFlow, or sorry, with Pytorch, you don't need NumPy because it already has the fun math. It's already baked into every tensor. It's already baked into every single tensor. So what's the point? What's the point? You don't need it. Okay. Okay. So now we're going to do Pytorch TensorBoard support. From Pytorch utils TensorBoard, import summary writer. No idea what that is. We're going to find out. From Torch utils TensorBoard, torch.utils TensorBoard, import summary writer. Did we get that right? Summary writer. All right. Don't know what it is. We're gonna find out. Now we need. I'm just gonna copy and paste this because there's a lot of stuff here. I don't really want to retype this all. So let's just do a quick little copy paste. I know we're gonna do. All right. So set paste. Paste that in. Set no paste. Okay. Thank you for the hearts. Appreciate it. Good to have you here. All right. So let's run this to make sure it works. I believe it should. So this is going to normalize our colors, our red, green, blue to 0. To center around just half. This is, I don't know if this is necessary. We're going to transfer it to a tensor. Then we're going to download our training data and our test data. Then we're going to load the data with a data loader. And we need to set number of workers to 1 because I know on my system it will break otherwise. And then we've got the output classes. T-shirt, trousers, pullover, dress, coat, sandals, shirt, sneaker, bag, and ankle boot. I don't know what the ankle boot is. I still don't. Then we're going to helper function for inline image display is going to show us a sample of our images. And I don't want to gray it out, because gray, let's make it pretty. Let's make it pretty. All right, so do we run that? We do, okay. So this is going to specifically just show us what images we've got loaded. So let's run this. Python TensorBoard. Let's see here, I forgot the as. There we go. Hey, yo, Betty White, how's it going? Welcome on in. Shout out from, oh, I see what you did there. I read it in my head before I almost said that out. But good old Hugh. Shout out to Hugh. And the last word that you got there. Yo, Betty White, thank you for stopping on by. Good to have you here. Okay, glad to have you here. Haha, have a blessed day. All right, Betty, appreciate it. Thank you. Okay, let's keep going, you guys. All right, so let's run that here. Now we should be able to run that. No module name, torch function. Yes, because I typed it wrong. We do have that function. I know it exists. Function. Oh, there we go. Easy, easy. Oh, Dean, how's it going? You're here. Welcome on in, Dean. Good to have you here. Happy Monday. We're just doing some Pytorch. We're becoming Pytorch experts today. That's what the plan is for today. All right. Now I should see on my screen. Okay, so we're downloading the data. And on my screen, I should see a very pretty single picture of some image. Okay. Or it fails completely. Why? I typed everything correct, didn't I? Data loader. I set the number of workers, right? What if we just deleted that? Let's just get rid of that. Let's see here. All right, let's try getting rid of the workers. I know it's a problem on my machine. Oh, it worked. It just didn't plot.show. If one channel, you have to do plt.show. There we go. That'll do it. That'll do. There it is. That's what I'm looking for right there. Now we got ourselves a little bit of a glimpse at some of our test data. Hey, Dean, how's it going? That's why I'm here. Low key, you're not into AI? Uh-oh. You're interested in machine learning. If you can't beat them, join them. Exactly. That's what we're doing here. We're going to join those AIs. We're going to make our way, you guys. We're going to make our way. Okay. So that's our training data. I do believe we should see another one. It should give some random. Yep. Okay. So we got a bag and some coats or something. A sweater, a sweatshirt. Not sure what that is. I want to see one more. Let's see what. And then we see more of the same. I see a boot. And then is that an ankle boot? Is that what that is? Is that an ankle boot? Is this what an ankle boot is? Let's see, zoom in on that right there. I think that's an ankle boot. Because it's not a shoe. I mean, technically it's a shoe, right? Okay. So the tutorial has a bug in it. It needed a .show. And the number of workers is a platform-specific feature that works on Linux. Maybe it works on Windows. Does not work on Mac. It doesn't work on Mac. Yep, that's what we got. Okay. Okay, let's do the summary here. Okay, let's check this out. Summary writer. Okay. Let's type this out. So I've never done this before. We don't need... I don't think we need to actually show any... We don't need to do anything here. I'm pretty sure we don't need that. I'm pretty sure. Okay. So, we're going to say writer. Writer equals summary writer. And then we say runs / exp, exp1. Or let's go with exp1. Let's see, mkdir runs. Okay. What else we got to do? Add image. Oh! Okay. So, maybe we do... No, is it image grid? Yes. Let me see here. Let me read through this real quick. Images, data... Okay. Torch vision, make grid. Yeah, so we don't actually need to run this, right? I'm pretty sure we don't need to run that. Writer dot add image. We call that the AMG grid. There we go. And we need to name it four images. We'll call it 4 images. 4 images. Just 4 images. And then writer.write? Is that what we know? Oh, flush. Okay, sure. We couldn't say right. We had to we couldn't say right because what? You couldn't. So you have to say .flush so that way we have more. We don't reuse the same word again. Okay, so let's run this. So we got something there by runs. Here we go. Runs. What is this? It is a TensorBoard summary. Ah, okay. So we're going to be able to open this in TensorBoard, and we don't know what this is. It looks like this is the image data. That's the image data right there. We also didn't need matplotlib, I'm pretty sure. We're going to find out, though. We're going to find out right now. All right, so how do we do this? TensorBoard logger. Okay. Which TensorBoard? We got it. It's installed. TensorBoard. We can't autocomplete it though. That's annoying. All right. TensorBoard. All right. And we say logger equals runs. Oh, it's giving us a place that we can load our browser into. Okay. TensorBoard. Whoa, check it out. See, I told you we didn't need matplotlib. I told you we didn't need it. Look at that. So it's giving us an image. So we can, what else can we put in here? What else can we put in there? I'm curious about it. Who's that? Oh, Woshi. Hey, Woshi, thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We're becoming Pytorch experts. If you want to join me together, let's go through all the Pytorch tutorials, and we're going to learn all of it. We've been building AI for many years now, about a decade. We've been writing AI from scratch. We even showed you, we proved it on Stream Live. We wrote a few models live from scratch. We use NumPy, we use Rust, and we use Python. And now we're learning Pytorch because I've not really fully learned all of Pytorch, and Pytorch has all of the industry standard state of the art. For the most part, algorithms baked into the framework. So we're going to go through all the tutorials, and we're going to become Pytorch experts, you guys. I'm really excited about this. Let's become Pytorch experts together. All right, so this is going to write summary. We're going to add an image, and you can do a whole bunch of things here. I assume you can write more. Let's do more. Let's do another one. Let's do even more. Let's do more images. Here we go. Check this out. For more images. There we go. All right. We do Python run. And then we can open up our TensorBoard. Again, we didn't need to restart the TensorBoard. Actually, what we could do is just say, here, let's run TensorBoard separately in another window. There we go, TensorBoard. It's called TensorBoard. There we go. Oh, no. Okay. Python. Run it, save, and now when we reload this page, we should see 8 images, right? 8 images. Here we go. Yep, there it is, 4 more. All right. We're learning how to use this now. This is pretty great. Okay. This is great. I like this. This is awesome. This is pretty fantastic. What I missed, Bone Soupy? Don't worry. We just, for the first time ever, brought up TensorBoard. I've never used TensorBoard before, and it works pretty well. It's okay. Would I want to use this? I don't know. Can you put pictures of cats in it? Yes. Yes, you can. You certainly can. If you want to. If you want to do that, with the data that we're currently loading is our MNIST data. There's probably a cat MNIST. Do you think there's a cat MNIST? Let's find out. Cat MNIST? No. Oh, maybe it's called cats plural. Is there a cat MNIST? No. That would be so cool if there was. Like feline or something. Let's see. Let's Google for this. I'm looking for a cat MNIST. Cat MNIST cat version. All right, just for you, Bonzubi, just for you. There's no direct cat MNIST built into Torch Vision. Oh no. The MNIST 70,000 handwritten edition. No, I'm not talking about. There's also fashion, right? If you are looking for a cat version of the dataset with Pytorch ecosystem classification, the closest equivalent is the pet dataset. Oh, well, okay, we'll do the pet dataset then. We'll do the pet dataset. Here we go. Let's see if we can make it work. Just for you, Bonzupi, just for you. All right, let's see if we got it. Let's see if we got it. Got an unexpected keyword train. We did not run. Oh. All right. How about we comment that out then? Oh, here it comes. Okay. Bonzupi, we might see a picture of a cat. We just might see it. We just might. I think it'll be pretty neat if we do. While that's going, let's continue on our tutorial. All right. Was this it? Yes. Okay. So where are we here? Okay. So we got about 10 minutes here. We got about 10 minutes left. If you start TensorBoard at the command, yep, we got to see it. We saw it. We saw it. All right. Almost ready. We're almost there, you guys. Oh, okay. And it should run, and it should... Oh, no! Stack expects each tensor to be equal size, but got... Oh, okay, let's see where we are here. They got different image sizes. So let's just not bother with... Wait, do we know what size it's going to be? Where did that fail at? Runtime error. We might not get to see the cat spawn, Zoopy. We might not be able to. Where are we, though? Right around here. Batch 0 output stacks. It's okay, LL. I know, we're really close. We're right there. I'm going to try. This was actually a good little project that we can get. 300 by 500 entry at a 3. Oh, right there. Okay. So instead of batch size 4, let's just do a batch size of 1. That might fix it. We might see. So we'll have to do a few here. We'll have to do a few. Maybe. Yeah, there it goes. Okay. All right, Bonzupi, here we go. Maybe there's a cat. We might get a cat. No, we didn't. What's going on there? Hold on. Why? What? What? Maybe you just have to get a pad the images. Yes. That kind of looked like a cat ghost. It looked a little bit, yeah. Let's close and reopen TensorBoard, maybe. It's the old data. Here. What we're going to do is leave that up and running. And we're going to say rm-rf runs. Here. There we go. That got rid of everything there. Rerun Python. Now, I believe there's no way for it to get any of the classes here. Because we're only loading the Oxford pet data. So that should work just fine to me. All right, let's see it. There we go. Okay, so that one's a dog. Oh, nope, dog. Okay. Redo. Okay, let's go until we get a cat. The same dogs. Wait, no, hold on. Wait. We might need to do something that... All right, we're almost there. We're like 2 seconds away from it. We're 2 seconds away. Can we maybe do batch size of 2, maybe? Maybe it won't have it probably will have a problem with batch size of 2. It might, yep, okay. So what we should do is... we should just put this in a for loop. Here we go. We're gonna get one. Don't worry, I promise. We're gonna get one. Okay. Oh, where is this at? All right, so where's flush at? Okay. So we're gonna rider. We're gonna add. All right, so for I in range 20. And then we're gonna do this. Rider.flush. At the very end, Okay. So we'll do cat or dog, question mark. Maybe something else, I don't know. Before that though, we need this to come here, and then we need to grab more images. There we go. Perfect, okay. So now we might get a cat. We might get a cat, you guys. Who's that? Shaheen, thank you for subscribing. Welcome in. Good to have you here. Happy to have you. We are becoming Pytorch experts. You joined the right channel for software engineering. What we're doing is today Pytorch with Python. And we're gonna see if we get any cats now. Oh, dog. Dog. Wait, I only get 2 dogs? Hold on. I want more. I did 4 more images. Hold on. Wait, let's see here. L runs. I'm just RF. Runs, EXP. Okay, so we might have needed to do that. Okay. Now we should see more. Oh, we didn't even get 1. Cat, we did it! Bunzubi, look! We got the cat. We got a cat, we found one. I know it's RNG. Why is it only 1? Oh, because we probably have to add them and flush them at the same time, right? How's it going there? Hexa, good to see you. Meow, we got a meow, we did it. We did it. Why'd my for loop not work though? That's kind of weird. So maybe we have to flush it each time. Let's see, RM. All right, let's try it again. Is that Pytorch, right? It sure is, Hexa. You got it. 1. Why is it doing just 1? Why just 1? Do we need, because it was doing 2 before. Am I missing something? This is just the iterator. We don't need anything special here. Hey Torva. Okay, Steven just sent mail to ask how stuff like that. Oh, right. For the bus data. Proposing the idea to work together with them, acquiring it while using EU protection laws so they don't just copy it. Nice. That's good to hear, Torva. Good job. Best of luck. Let us know how it goes. Can you talk about attention in terms of AI? I'm still trying to figure it out. So attention is the idea of, I call it the correlation coefficient matrix. And they're different purposes between an attention output, an attention matrix and a correlation coefficient matrix. The reason why I like to reference that is because they're very similar. The correlation coefficient matrix, why? We're gonna figure this out, you guys. We want more than 1 cat. So by the end of today, we're gonna get more than 1 cat here. We're gonna get more than 1. There's, all right, we got another one. We got a second one. Okay, so the writer should be able to add more than 1 image at a time. I think this is very odd. It's very odd. I feel like I'm using TensorBoard properly. Okay, so let's see here. So with attention, how do we want to do this? Let's walk through attention really quick. So we're going to have a bunch of numbers. Let's zoom in on here. Each of these numbers, let's say, represents a word. Let's keep it simple. In a correlation coefficient matrix, you're going to take every word and multiply it by every other word. So let's create a little, can we do arrow with a bounce to it? All right, so we're going to go, I want to bounce it. How do we do this? I want, try that, there we go. Yes, there we go, perfect, okay. So 8 will be multiplied by 4, and then we're gonna do that again. You know what, I'm gonna do this with just a regular draw pencil because it's easier to deal with. All right, so 8's gonna be multiplied by 4, but it's also gonna be multiplied by 1 and also by 5, right? And that's going to give us an output value across the relationship in distance and between these values. And the same thing will happen again for 4 will be multiplied by 1 and be multiplied by 5. And it's going to generate a second matrix. And that matrix is going to have sort of a really pretty pattern. And that pattern is going to be sort of large numbers in the center and small numbers out on the edges. That's going to be the correlation coefficient. And similarly with the attention matrix, you do the same thing, but you do more steps, right? So let's do this. All right, so attention equation transformer. We're going to see that represented as QW here. So here, this is the full attention right here. It's really easy. It's actually pretty straightforward. So Q and K and V are the same values, right? So you need to input it. It's essentially multiplying the matrix by itself. So you have one matrix and another matrix, and then you multiply the two matrices together. One is transposed, I believe, so that creates the ability for it to be asymmetric, which is fine. And then you do a little bit more math. So you take the square root of what is D. I don't know what, I forgot what, I think this is like some sort of number of values or something. And then you multiply softmax and then have some sort of constant. That's all that is. I think it's actually really simple. So it's just matrix multiplication with a little bit of extra math around it. That's attention. That's all it is. So if we have like cat, like if we have a bunch of words here. So let's say, let's try this. To make it simpler. So we have cat ate the grass. We'll try that. Cat ate the grass or something like that. Right? So simple sentence. Then each word's going to be converted into a token, which is an index. So like a number 1, 2, 3, or 4, or a one hot encoding. We don't need to go there. And you're going to multiply these numbers together. So cat multiplied by the and multiplied by grass, right? So you're essentially multiplying itself. So it's called self-attention. There you go. And then 8 with the grass and 8. There you go. And that's going to give you another value. And the same with the. So the and the grass. And that gives you the output. How does this work? Orthogonal? Hey, D, how's it going there? TD0? What is that? You've never heard about that. NGL, you were enjoying the dogs. You were enjoying the dogs? Well, we still got more. We're gonna see if we can get a few more in here. So we got a cat. So before we leave today, we've got one remaining task. One remaining task, you guys. I want to get more than one picture on the TensorBoard. More than one picture. I think we can do it. I sure do. The most recent commit is the state of the code base as the end of the last stream. Yes. I don't know why you said that, Bonzupi, but yes, it sure is. I've been understanding tokenization, just the beginner stuff in the minute. Oh, tokenization? Okay, so tokenization is just converting words into an index and then converting that into a one-hot encoding and then through an embedding. So it's actually not that tricky. So let's tokenize this sentence here. If you're still here, let me know, because I'm going to walk through it right now. Let's tokenize this sentence. So we'll do another sentence here. All right, so we'll say the cat jumped, something simple like that. We're going to say there are 3 words in our dictionary, and we're going to assign a number. So this will be 1. Let's see, there's 8. This will be 2. And then this will be 3. Let's see, 3. 8, 3, go. Who's that? Who did that? Nuno Giro, thank you for subscribing. Welcome on in. Happy Monday. You joined the right channel for software engineering. We're becoming Pytorch experts, you guys. Yes, we are. Yes, we are. And I'm going to show you about tokenizing. We're going to do that right now. We're going to tokenize these things. So first you need to create an index. Right here, create an index. So this is a 3. So you've got, these are the index IDs, right? And then you're going to convert those into one hot encodings. So let's do that really quick. So this is going to be 1, 0, 0. This next one is going to be 0, 1, 0, right? Because it's the index based in an array. And then we're going to do jumped. This will be 0, 0, all right? And I bet you can guess it. What's the bottom one? I bet you know what the pattern is now. 1. There you go. So we have a 3-word dictionary, and you're probably going to have a lot more words in reality, right? 1,000 words, 10,000 words, as many languages as you want. So you create the meaning. And so this represents each word in an index, right? So now you've vectorized the data. You've tokenized it. What you need to do next is run this through a batch embedding, which is going to reduce these into specific meanings. And it gets better over time. So instead of having an array like this, you're going to have an array that looks a little differently. Let's type that out really quick. That's going to convert your array to something like this. It'll be 0.3, and it'll be like 0.1 and 0. This is like a simplification, right? So what we've done is we've reduced the dimensionality by 3x, right? So we've gone to a 3 vectors into, which is a sentence, right? Into a single dimension per index. It's going to be able to represent the meaning of each of these words using a float rather than a full index, which is really helpful because training can get sped up and you can derive meaning with relationships in between your numbers. Never have I explained so much as an entertaining mob programming session. Oh, really? Seriously? That's great to hear. If you want, you can join the Discord link. And yep, Bonzupi. I think Bonzupi did its show that time. Gustavo, thank you for saying hi. What do we got here? Transformer. Yep, we're walking through. Someone was asking how does tokenization work? So we just walk through that really quick. Really easy, right? It's just taking your numbers and converting them from your words, converting them into numbers. Have a wonderful day, you too, Zergio. Hope everyone's having a good day. Mohammed, looking good. Let's see here. See if I miss any chat messages. Get repo must have been blocked because you shared the link. Yes, Bonzupi, yes. Yeah, if you throw it in Discord, it will show up in Discord. We got it there. Okay. Gustavo, there you go. Transformer. It's like the beginning of a transformer, right? It's like this before you get to. So this is the encoding, essentially the encoding part. And then now that you've got your embedding, which has created this new vector here, or this new essentially new sentence. Let's call it a sentence because that's what that is. You can take this and throw it into a transformer. You were trying to show Hexa where you got the GitHub. Oh, for the stream. Oh, yeah. Okay. Let me add all this here. So before we leave today, I want to do one thing. Oh, wait. Git status. Let's exclude data and runs. Okay. By.git ignore. We're going to exclude data and runs. There we go. Nope. There we go. We don't want those things to go into our repository. Git add. All right, git status. All right, we added pooling. What do we else? Pooling. We did norms and TensorBoard. There we go. Push to main. Boom. Did you suffer from procrastination before starting your current company? Yes. Sure did. I was playing a lot of video games on the Wii, on the Nintendo Wii. A lot of video games, you guys. Remember me, sir? Waity, Shrew Jank, Harwad. I don't know. I know you're all smiley there. I don't know. I can't say yes, though. I might remember if you tell me what you said previously. I read your comment probably, and I'll remember you then. Guess Hexa will have to join the Discord if he wants to get your GitHub link. Yes, definitely. All right, so just for you, Hexa, let's grab that here real quick. Copy. So we say at hex. Are you there? Maybe they left. Here you go. Well, there's the Discord link either way. You have to crawl through a couple repos, but it should be easy to find. Nice. Sounds good. Okay. Have you done any network programming programs before? I sure have. Yes, I have. Not just a smidgen, but maybe among the world's largest. That's where I come from. I have built this technology and I've got patents on it. A distributed compute patent. I'm Stephen Blum, CTO at PubNub. We raised 134 million Series E. I have over 1 billion devices on my network. You guys, 1 billion devices. and they do a lot of things like multiplayer games. It's all network communication. It's all of it. Financial stock quote updates, call centers, transportation, order delivery, gaming, right? When you're playing casinos, sport score updates, multiplayer games, healthcare, telemedicine, e-commerce, livestock, live bidding, live bids. If you've done those, you've used my technology. We are the top 10 apps in the App Store today all have built-in app communication. And that's the technology that I do. That's crazy, dude, isn't it? It is. That's me. I've been doing that. I've distributed messaging infrastructure. So networking, yes, I've done this many times. Can you adopt you, Mark Lemon? I know, yeah. A little bit of adoption there. Grab some, exactly. There's a bedroom. I've got a bedroom that nobody's using. Let's see here. I'm going through the chat to make sure I didn't miss anything here. Good to have you guys here. Happy Monday. Let's see here. So yes, networking. I'm in that phase low key. You got the last 10% and just got super hesitant. Oh yeah. Well, you just got to jump in, and it's hard. Just jump in, edit, go, and you know what? Here's what's going to happen. It's okay. When I say this word, don't panic. It's called failure, and it's your best friend. Failure is a special capability that humans have. We have the ability to recognize failure. That failure is what teaches you, and you know something's wrong. You recognize failure, and you know to go back and fix it and try again. That failure is the most powerful thing that humans have. Hi, Steven. How's it going there, Dennis? Good to see ya. You gave up learning too? And then you went to Claude Code? Yeah, I know. Naturally, you're a builder. What's next for people like you? How do we gain an edge? Well, I think you just wait for the better AIs to come out, right? You don't have to do anything. You just sit back, like, hey, we're just gonna sit back here. We don't have to do anything. Just sit back and wait for the AIs to get a little bit better. All right, Dennis? And you know what? We need your help too. We need more engineering in the world, not less. How's it going there, worlds? Good to see ya. Oh, I missed your message. Okay, so you got moderated. You done got moderated. All right, so thank you for the hearts. What we need to do here is I want to do one last thing. If you guys have any more questions about attention, this one's a really easy, straightforward one, or how tokenization works. That's all the easy entry point stuff. It's embarrassing, is it? You're okay with failing? A fire got lit under you because you showed some prospective customers your product, and you're targeting government contractors. Nice. They are hitting you up and asking you when they can use it. Mohammed, you're onto something. That's one of the most important things. You got to get users. You got to get revenue. All right, let's do the last thing today. I want more than one dog. That's what I want. I want more than one. More than one. How do we do it? How do we do it? So let's do an RM on the run, and then we say and. We don't say and. We just do the next thing, which is Python TensorBoard. There we go. Okay. Let's see if we got it to work. So we got one cat. There we got another cat, but it's just one. I want 20. I want 20 of them. How do we do that? Maybe if we read more on the TensorBoard, we could figure this out. Let's see here. La la la, la 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 la. Visualizing your model. Add graph flush. Maybe we only need to flush once. Let's try it again. Let's see here. How's it going, everyone? All right, catching up on some of the chat messages. What do we got over here? Let's see here real quick. Even under NASA's motto, failure is not an option. Oh yeah, thousands of failures behind the scenes. Yes, they've failed so many times, so many ways that when they go on the big day, when it comes, they're all ready and they're ready to go. Exactly. You need to fail as often as you can to learn where that failure can occur, so that way you fix it to prevent those failures in the future. Also, you should expect failure and build in contingencies just in case. The thing can go wrong and they can prevent failure. Yep, when it matters the most. You got it. It's called faults. You got to protect those faults. Except for the challenger. I know, Bonzupi. I know, that was sad. Honestly, I need to get just this, get it done. And you want to build other things too. Hey, Mohammed. Yep, you're right. It's a lot of work. It sure is. Why are you calling the next at the start of the end loop? Oh, yeah, because this isn't, oh, wait, you're right. We don't need to do that. Thank you. Hey, thank you for paying attention. We just fixed, yeah, we don't need this. We don't need it twice. Why do we have it? It's not necessary. I don't think it'll hurt. I don't think it hurt it, but it's an improvement. Thank you for paying attention. That's amazing. All right. So still just one picture. Still got one picture there. Is there a way to see more than one here? Or is it because we have to say, we have to do it like an F string. Here we go. F string. And we have to label it different for every image. Maybe this is the problem we had, right? Here we go. Cat or dog. Here we go. All right, here we go. Let's see if that was the trick. We might have gotten it. You're a cool guy, Steven. Well, thank you, Mohammed. Appreciate it. That's a great compliment. Well, you're a cool guy too. All right. Always ready for failure. You can risk stuff as long as you have something to fall back on. Got to have those contingencies. You got it. All right. Let's see if I fixed it, you guys. All right. Before we do this, let's see. All right. Should we see? Let's see. Wait 1 second. Hold on. There's something I clicked here. Members only live. New. Schedule your live stream to switch to members only. What does that button do? Not available for portrait streams. Oh, okay. Well, why have the button there? Why is the button there that I can't even use it? All right. Will we see 20 animals in TensorBoard with our fix? With the fix. All right, you guys. Let's see what you got. Did we fix it? Do you think it was because we needed to give the title a unique name? I think the answer might be yes. I think it might be yes. It might be yes. All right. We're going to find out. Here we go, you guys. Here we go. Let's run it. Let's make sure. Okay. Run. It ran. Now on TensorBoard, because we added a unique label for each of the output sections in our segments, we should see more than one. If we don't, we're going to stay here until we figure it out. Here we go. Did you guys get it right? No, wait. It's still got a question mark. That means it's old. Wait, so that did not work then. 1 second. Runs. rm-rf. Runs star. Yes, delete everything. Okay. Then let's... Hey, there we go. We figured it out. Check that out, you guys. Okay, it did work. We fixed it. That's all it took. You know, it would have been nice. It would have been nice if they told us. It would have been nice, right? Wouldn't it have been? I think it would have been much nicer if they told us. We'll zoom out here. We'll zoom in this way so we can see more. There we go. So, cat. Oh, dog. Cat, dog, cat. It seems pretty even. I think we've got like a nice even amount of cats and dogs here. We did it. We succeeded. We used TensorBoard. Do we really want to? Do we really want to use TensorBoard? Is that something that we should be using? What do you guys think? I'm not sure. I haven't yet run into my limit on TensorBoard, whether I think it means that I want to do it or not. I'm not sure. So what we're going to do is, we're going to do more TensorBoards tomorrow. Let me see here. We will scroll through. Where is this at here? So we finished that part. We're going to go on graphing scalars to visualize training. This might turn me on to TensorBoard. This might be, oh, I should be using TensorBoard because of the graphing scalars. Is that why you use TensorBoard? We're going to find out. That makes so only members can type in the chat. Yes, exactly. Oh, is that what that is? Okay, Torva. It is successfully classifying the dogs and cats. Well, we're going to find out. We're going to create a convnet, and we're going to have 3 linear layers in a pool, which is going to grab the edges, and we're going to feed that through our forward, and then we're going to optimize it, and we're going to see where is our output for the TensorBoard. Here we go. So this is the main part that we want to take a look at. So this is our plan for tomorrow. We'll be getting started on this tomorrow. So this week, we'll have shorter streams for the rest of the week, Tuesday through Friday. And we are going to stream for as long as we can. However, we've got like a meeting that's going for all day long for the rest of the week. It's a big meeting. It's a very big meeting. The plan is we need to stream during lunch, essentially. So I'm taking lunch to stream with you guys. So that'll be starting tomorrow around 12 o'clock, 1 o'clock that time, I believe. And that's the plan. Good to have you guys here. We're headed on out now. It was good to see you. No problem, Torva. Sounds good. Thank you so much, everyone, for joining. We'll be back tomorrow, and we're planning to graph our scalars and visualize our training. We're going to use TensorBoard and see what that's like. Had a lot of fun today. Thank you again for joining, guys. We'll see you tomorrow. Bye, everybody. Have a good day. See you next time.